Similarity in right triangles. Our objective is to use geometric mean to find segment lengths in right triangles. We're going to apply similarity relationships in right triangles to solve problems. Why learn this? You can use similarity relationships in right triangles to find the height of triangles. You might want to know what the geometric mean is first. The geometric mean of two positive numbers is the positive square root of their product. So if x represents our geometric mean, it equals the product, so a times b, and then the square root of that. You can rewrite the equation as x squared equals a times b. Let's try a few examples. We'll try a together, and then we'll try the other ones on your own. So, if we use x as our geometric mean, we know we need the square root of 4 times 9. Well, 4 times 9 is 36, so we have the square root of 36, and therefore x equals plus or minus 6, but we know that we can't have a distance that's negative, so we're just going to use 6. Take a moment and pause the video and try B, C, D, and E. Now that you've had a moment to try B, C, D, and E, let's see how close you came. So, for B, we want x equals the square root of 10 times 30, which is 300. Well, there's no nice square root for 300. You can simplify this and understand that 300 is the same as saying 100 times 3, and you know what the square root of 100 is, and that's 10. So x equals 10 square roots of 3, since there's nothing you can do with the 3. Let's look at C. We have 2 and 8. So x equals the square root of 2 times 8, which is the square root of 16. And the square root of 16 is, once again, plus or minus 4. But since we're dealing with distance, we're going to utilize just the positive 4. Let's look at D. For D, we have 6 times 15. So x equals the square root of 6 times 15. 6 times 15 is 90, so we have the square root of 90. Similar to B, the square root of 90, there's no easy number that we can take the square root of and have a whole number. So we end up splitting 9 and 10 because we know that there is a square root of 9. So square root of 9 times 10, and we can take the square root of 9, which is 3, and the leftover kind of just stays underneath. 3 square roots of 10. Let's look at the last one here. We have x equals the square root of 8 times 9. Well, 8 times 9 is 72. So we have the square root of 72. And similar to B and D, there was no nice one that we can utilize, but we know that 36 times 2 gives us 72. So we can have the square root of 36 times 2. Because 36 is a perfect square, so we know we've got 6 square roots of 2. Let's analyze this idea inside of triangles. Using geometric means. So, if you look at our diagram here, if you want to figure out what the one inside is, so this height, you would do height squared equals your x times your y. So, geometric mean. So h squared equals x times y. When you're dealing with the outside of the triangle, you want to end up using the whole side c. So you're going to need to add whatever number x and y is to get c. So it's a squared equals the one that's on the same side of it times the whole thing. For b, it would be b squared equals the one that's on the same side here times c. Let's try a couple. Take a moment and pause the video and draw the diagram. Now that you've had a moment to draw the diagram, let's try this problem together. Well, we have the h, which was the one that was on the inside. So in this case, we're using the letter x. So x squared equals, and then we look at our longest side here, which is 2 and 10, and we multiply the two small pieces. So that's the small inner piece, gives you multiply the two small pieces. So we have 2 times 10. Alright, well, x equals the square root of 20, and there's no nice square root of 20, but we can split this into 4 times 5, which will give you 2 square roots of 5. Let's look at y. Now, in the formula we stated that, remember, they go, if they're outside, one pairs up with the one on the same side, and then we add up our whole c here, and in this case it's 12. So y squared equals 10 times 12. Or you can think of it as y equals the square root of 120. And just like with the x, there's no nice square root of 120, but we can split this up into 4 times 30, which is 2 square roots of 30. Notice every time we try to pick a number that's a perfect square. If it's a perfect square, that's how we can kind of get rid of it, essentially speaking. Let's try z. So we have z squared equals the one that's on the same side. So we've got 2 times, and then the total, which was 12. So we can state that z, sorry about that, just z, that z equals the square root of 2 times 12. Well, 2 times 12 is 24, so we have the square root of 24. 24, you can split that into the square root of 4 times 6, which is 2 square roots of 6. Take a moment and try the next problem. Now that you've had a moment to try this next problem, let's try it together. So we're looking for u. It's going to be helpful to know what u is before we figure out w and v, since u is on the outside. Well, we've got our h squared, which is our 9, so we have 9 squared equals our 3 times u. Our little one times our little one. So we have 81 equals 3u, and we want to solve for u, so we divide by 3. So divide by 3 on this side of the equation and divide by 3 on the other. U equals 27. Okay, so there's one of them. Okay. Now that we know that U is 27, we can also state that that means C is 30. And I'll write that up there just to kind of help us out. So we can go for V or W, doesn't matter which. So we'll keep it in the same order and we'll go with V. So we have V squared equals 3 times 30. 3 times 30. Notice we picked the one that's on the same side here of the triangle. So we have 3 times 30, which is 90. And since we want V by itself, we're going to take the square root of both sides. So we're going to take the square root of 90. And it's not a nice one, but we can take the square root of 9 and 10, which gives us the 3 square roots of 10 that we're looking for. And that would be our V. And one last letter. So we have W. Similar to what we just did, we can do W squared equals, well, that's on the same side, so 27 times 30. And we would want W equals the square root of 27 times 30. And let's see, 27 times 30 is 810. So we take the square root of 810, and we know that we can split this into 81 and 10. So 81 times 10 here. And the square root of 81 is 9, so we have 9 square roots of 10. And that is our W. That concludes our lesson on similarity in right triangles. If you have any questions, ask your teacher.